Welcome back to You Revise, where we talk about everything exams. Let's take a look at question 5 from the 2016 exam. It reads, which one of the following substances completes the equation illustrating the process of trans-esterification to produce biodiesel? The equation reads, triglyceride plus another substance to produce ester, which is an ester, which is a biodiesel, and glycerol. Now, we're given the answers here. We're going to go through them. But first of all, let's take a look at this here. According to the examiner, 68% of candidates got this question right. And this one is a recall question more than anything else, where you just had to remember. If at any point you don't remember the general trans-esterification reaction, you would have struggled with this. Now, when we carrying out a trans-esterification reaction, we use glycerol according to what the the question is saying, which looks like this here. R, and then here I've got double bond carbon R, and then the same here I've got carbon double bond oxygen and R. This R is just like a long chain of carbon atoms that continue this way. I'm not going to go into the detail of this, but yeah, that's what a triglyceride looks like. Now, if you react this with methanol, right? If you react this with methanol, trans-esterification takes place here, where you produce an alcohol, a triol, which looks something like this. OH, 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 and we get H2 here, and we've got 1, 2, H2, and then we get H2 here. Let me see now, this one still remains H. I don't know why I'm putting an extra hydrogen here, because this one has got 3 bonds, this one has got 1, 2, 3, 4. Yep, that's fine. This is what the alcohol produced looks like, which is the glycerol. And the ester, the biodiesel we get, because I don't have enough space here, I'm going to draw the ester here. So the ester would look something like this. We've got R, which is this chain, and then I've got double bond oxygen, and here I'm going to get CH3 on here. So this is what the ester will look like. We draw this double. This is what the ester biodiesel looks like. That's the structure. But because when we break this around here, because we've got this here, we're going to have 3 lots of these. And this reaction is carried out in the presence of a catalyst. This catalyst can be sodium hydroxide, potassium hydroxide, or any group 1 alkaline solution. Or we can carry this out under using lipase as an enzyme, as a biological catalyst. So we can use an inorganic catalyst, or we can use a biological catalyst, which is lipase. Just to extend you a little bit more so that you get to think about this, because already I've given the answer, we've got to the answer here. You can pretty much tell the answer is B, because I said methanol. I've given the answer, but just to extend you a little bit more, some of the things you have to think about, especially when you are revising, you see a multi-choice question like this. Try to think about, is it possible for the examiner to ask me this concept in a short answer or extended answer question? And as you work through past exam papers as well, you're going to get to a point where you come across this biodiesel question in a short and an extended answer section. So what have I come across in the past? What have I seen happen in the past? Usually you might be given a question, just give as an example, a question to explain, or to state and explain or outline the advantages and disadvantages of using either a biological catalyst over an organic inorganic catalysts like sodium hydroxide or vice versa. Now, just you'll be wondering how would I answer that question? Now, this catalyst here has got its advantages and it has got its own disadvantages, which you can also go and revise. I'll just cite a couple here, and then you go back and look at these in your own time. So, a sodium hydroxide is actually corrosive. Now, as we know that catalysts don't get used up in a chemical reaction, what happens if that catalyst is disposed of? It can be corrosive, it's dangerous to the environment. That goes against the green chemistry principles. But look, at the end of the day, it's still used. Why? Because it has got an advantage. The advantage of this is this reaction can be carried out at a higher temperature, which means we can produce biodiesel much faster. Now, another disadvantage of sodium hydroxide is if you react sodium hydroxide, if you replace this with sodium hydroxide, you end up making glycerol, and instead of biodiesel, you make soap. So if the ratios of the catalyst to the reagents and the reagents themselves are not managed very well, you end up with soap as a waste product, which means you have to purify the biodiesel, or if you put the biodiesel in the engine like that, it's not going to work very well. It's not going to be effective. So that's the disadvantage of sodium hydroxide. Lipase, unlike sodium hydroxide, it's environmentally friendly, number one. Number two, reactions can be carried out at lower temperatures, which is cheaper, but the disadvantage is it can be the rate at which we produce the biodiesel would be a slow rate. And like we said, getting back to the question, I apologize, I digressed a little bit, but I just thought I would, give you an opportunity to go through this. It's a way of revision. If you know it, you can just move on. Now, this one here, the missing word here is methanol. Okay, that brings us to the end of this question. I shall see you when you attempt the next one. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.